Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homix Middle School Earth Science Department. Today we're going to focus our attention on page 6 in the reference table, your igneous rock chart. Now your igneous rock chart, there's a couple different components here in terms of how to read this chart. There's a lot of information that you need to be able to grab out of this. So let's start out with the very, very top of this chart first. And probably the most important section is going to be your texture. Texture is basically going to be crystal size, and that's how all your igneous rocks in this chart are going to be organized. Glassy, fine, coarse, and very coarse. And you also have gas pockets with some of these rocks, which we call vesicular. Next to that is going to be your actual crystal size. The crystal sizes are going to correspond with the actual description of texture. So your very coarse rocks, which can be non-vesicular, are going to be 10 millimeters or larger. Your coarse rocks, non-vesicular, are 1 to 10 millimeters. Your fine rocks, which are less than a millimeter, can be non-vesicular or vesicular. And your glassy rocks, which are non-crystalline, almost instant cooling here of the lava, okay, are going to be either non-vesicular or vesicular. On the left side, this is your environment of formation. Okay, you have your intrusive rocks. Intrusive rocks can be formed deep below the surface, really, really slow cooling of the magma. Okay, and that's going to include your very coarse rocks, such as pegmatite, and your coarse rocks of granite, diorite, diabase, gabbro, peridotite, and dunite. Above that, you have your extrusive rocks, and that's going to incorporate your fine rocks of rhyolite, andesite, diabase, and basalt. You notice diabase actually has both characteristics. Remember, extrusive rocks are your volcanic rocks. They're going to form very quickly through the solidification of lava, so your crystals are going to be really teeny tiny, and sometimes, in some cases, you don't have any at all. You also can get some fine rocks that are also vesicular. So you have vesicular rhyolite, vesicular andesite, and vesicular basalt. They're going to be fine with gas pockets. Above that are going to be your glassy rocks, instant cooling of lava. Pumice and scoria are glassy with gas pockets. Obsidian and basaltic glass are glassy without gas pockets. Okay? So below all your rocks, you have your different characteristics. Color, left side of your chart are light, right side of the chart are dark. Left side of the chart have a low density, right side of the chart has a high density. Left side of the chart has a felsic composition made up of silicon and aluminum. Right side of the chart has a mafic composition, iron and magnesium. So very important to identify that you don't necessarily read this chart horizontally, but you can also read this chart vertically as well. So your rocks on the left, obsidian down to pegmatite, are your felsic rocks. The rocks on the right, from basaltic glass down to gabbro, okay, those are all going to be your mafic rocks. So definitely need to know the difference between the two. The rocks in the middle have a combination of both characteristics. So that leads us into our minerals down below. The minerals are the building blocks of rocks. So your lighter rocks, your felsic rocks on the left, are going to contain really light colored minerals. The characteristics of the minerals are going to carry over to the rocks. The rocks on the right, which are darker, those are your mafic rocks, they're going to contain very dark minerals as well. So the characteristics of the minerals are carried over to the rock. Okay, the characteristics in the middle, those rocks actually have a mixture of mineral compositions, so they're going to kind of fall right in the middle. So, your lighter rocks, your felsic rocks on the left, these rocks from obsidian down to pegmatite contain these minerals here. The rocks in the middle contain the minerals right in the middle as well, so they're kind of an average of both sides. From basaltic glass down to gabbro, they're going to be your darker rocks, they're going to be your mafic rocks, they're going to contain the minerals right below them. Peridotite is kind of special because it's only made up of 2 minerals. And then dunite is even more special because it's monomineralic. It's only made up of 1 mineral, olivine. Now you'll notice each one of your minerals has a different pattern, and those patterns are going to be characteristic based upon where they're going to be found. So the patterns on the left are only found in the rocks on the left. The patterns on the right, those minerals are only found on the rocks on the right, and so on. So if we're going to actually go through and try to identify some of these rocks with characteristics, granite, for instance, is going to be intrusive. Granite is coarse-grained, so big crystals, slow cooling. It's going to contain the minerals directly below it, which means that it's lighter in color, lower density, and a felsic composition. Obsidian, extrusive, really quick cooling because it's glassy in nature. It's going to contain the same minerals as granite. The big difference here is cooling time. Okay, and again, that's going to be a lighter rock. Even though it appears black, it's considered a lighter rock because in real thin sections, obsidian appears completely clear, lower density and a felsic composition. And then finally, we'll just take basalt, for instance. Basalt is extrusive, quick cooling, because it has small crystals. Okay, it's going to contain the minerals directly below it, and it's going to be a mafic composition. So I hope this helps out. Really make sure you know how to read your reference table, especially your rock charts. Rock charts get a lot of information. Okay, your igneous rock chart is going to be very important for you to know. So that's it for now. Good luck, and we'll talk to you soon.